Trigonometric ratios part 2. Our objective is the same as it was in part 1. Using trigonometric ratios to find lengths. Find each length. Round to the nearest hundredth. So in this case, we want to find AB. We're going to do the first few together, so that way you have some idea what's going on. So I suggest highlighting the side in which you're trying to find. So in this case, AB is the side which we're trying to find. We're given that angle A is 41 and that CB is 6.1. When you're looking at the angle that they gave you, which is this one here, and then the two sides that you're trying to relate, you have the opposite and the adjacent. It's in reference to the angle measure they gave you. Now angle C, which you would have to deduce using the fact that a triangle is 180 degrees. So, using that angle A is 41 degrees, we need opposite and adjacent. The only trig ratio that dealt with opposite and adjacent together is tangent. So, you're going to take the tangent of 41 degrees has to equal your opposite, which is 6.1, over your unknown. You want to solve for your unknown. So you would multiply both sides by x since it's in the bottom of the fraction. So you're going to multiply both sides by x. So now you have x times the tangent of 41 degrees equaling 6.1. And now we can actually feasibly get x by itself. So we can now divide both sides by the tangent of 41. So the tangent of 41 on this side as well. And that means we are left with x equals 6.1 divided by the tangent of 41. And you could enter that in your calculator just as you learned in part 1. Which, in this case, shouldn't say equals, it's about, since we're dealing with decimals here. We have 7.01, and in this case we're using inches, so about 7.01 inches. Let's try a couple more. It wants us to find the length of MP. Well, let's highlight MP to make sure we know where it is. MP. Okay, so now that we have MP, we look at what they gave us. They gave us this angle N. So, and then we have our 8.7, which is our hypotenuse. And then they want us to find the side that is opposite the angle they gave us. So, we look for which trig ratio deals with opposite and hypotenuse. Well, in this case, it's sine. So we have the sine of 20 degrees equals your opposite, which is your unknown, over your hypotenuse, which is 8.7. We want to solve for x, so we can simply multiply both sides by 8.7. So on your calculators, you can just insert sine of 20 times 8.7. Just be mindful, when it shows up on the calculator, I'll do this in green here. When it shows up on the calculator, you want to make sure you close off those parentheses before you put in times 8.7, just so that way it's not finding the sine of 20 times 8.7. You want the sine of 20 and then that value times 8.7. And that will give us that x is about, let's see, 2.98. And we're dealing with centimeters here, so 2.89 centimeters. Try this one on your own. Now that you've had a few moments to try it on your own, let's see how close you came. So, we're looking for YZ. So we want to highlight YZ to make sure we don't mix anything up here. So we've got YZ, and that would be our hypotenuse. So that's our hypotenuse. And we're given this angle Z. We're trying to find our hypotenuse, and then the other side they gave us is adjacent to the 38 degrees. So we're looking for the trig ratio that deals with adjacent and hypotenuse, and that would be cosine. So we have the cosine of 38 degrees equals the adjacent, which is 12.6 over your hypotenuse. So we want to get x by itself, but first we got to get it out of the denominator, so we're going to multiply both sides by x. So now we have x times the cosine of 38 degrees equals 12.6, and now we can feasibly get x by itself. So we're going to divide both sides of our equation by the cosine of 38 degrees. And the cosine of 38 degrees over here. And now we're left with x is about equal to 15.99. And then our units are centimeters. So centimeters. If you got that one, great. If not, hopefully my explanation made it make a little bit more sense. But let's try another one. Now that you've had a few moments to try this one on your own, let's try it together. Well, we're looking for DF. So let's highlight DF. So we've got DF, and now we want to figure out what we're going to use. So they gave us that angle D is 51. We're trying to find the hypotenuse, and the other side they gave us is opposite this 51 degrees. So we have opposite and hypotenuse, and so therefore we're using sine. We have the sine of 51 degrees equals our opposite, which is 17, over our hypotenuse, which is our unknown. Once again, because the x is in the denominator, we want to get rid of that, or move it out of where it's at. So we're going to multiply both sides by x. And then you have x times the sine of 51 equals 17. So x equals, or 17 divided by the sine of 51, and that gives us that x is about 21.87, and our unit of measure is meters. Let's try a real-world application. A contractor is building a wheelchair ramp for a doorway that is 1.2 feet above the ground. 1.2 feet above the ground. To meet ADA guidelines, the ramp will make a 4.8 degree angle with the ground. To the nearest hundredth of a foot, what is the horizontal distance covered by the ramp? Well, the only measurements that we are missing are this AC and this CB. AC is not horizontal. CB is. So that is what it's asking for. So let's highlight to make sure that we grab the right information here. So we want this bottom side here. Okay, so now let's look. We've got angle C. They gave us the opposite here. And they want us to find the one that's adjacent. So the only trig ratio that deals with opposite and adjacent is the tangent. So tangent of 4.8 degrees equals our opposite, which is 1.2, over our adjacent. We want to get our unknown out of the denominator, so we now have x times the tangent of 4.8 equals 1.2. So then we're going to divide both sides by the tangent of 4.8, so x is about 14.29, and then we're dealing with feet, so feet. That concludes part 2 of trigonometric ratios. If you have any questions, ask your teacher.